own Lorentz compass. Submersible pumps, usually the more popular one to go for. Very basic software. You can use current pumps, all pumps, custom pumps. I use current pumps. Click on location and start typing, then we'll reach it. Most of the regions in Southern Africa are listed, or you can go, if the customer gives you a location and you cannot find it, look for an alternative as close as possible via Google Maps, Google Earth, etc, etc. You're going to need basic parameters from the customer, like in the depth of the hole, the volume of water that you want to displace, the depth of first water, if there's a drawdown. The drawdown is usually from the top of the borehole where your water level is once the pump starts pumping, and if it's not a very strong hole, the water level goes down. Now that is your drawdown level. Now to the maximum drawdown level, you can pretty much sink the pump up to 5 meters below that. Most people prefer sinking the pump to 5 meters from the bottom of the hole, if that's allowed, if the water level is 5 meters above the bottom of the borehole. Suggested 5 meters from the bottom, not to suck up any mud or sand or residue. Usually we start off with the total dynamic head. Total dynamic head will be from the mouth of the pump to where your water is going to be displaced. Now in this diagram it's a water pump. So let's say for instance the customer has a 45 meter head. I usually go 5 meters extra just for a slight bit of over engineering. But his borehole is only 20 meters deep. The pump will be then situated at 15 meters, so you're going to allow for the 15 meters down the hole and approximately 5 meters outside the hole for your cable. You don't always spec your cable as the same depth or the same length as your dynamic head. Pipe length, that's for in case you run long pipe distances and the tank is not situated next to the hole, then you can add a pipe length. Let's say for instance the tank is 120 meters away from the pump itself. That will be your 15 meters depth of the hole, the pipe running down there, and then obviously 105 meters across. Pipe type, you can select plastic or steel, all depending on what the customer already has in. Now on the daily required output, certain customers will give you an hourly rate that they require, a certain amount of water per hour. Other customers will give you a daily rate required. Now for this selection, we're going to say the customer needs 2,000 liters per hour minimum. So the rule of thumb is, if it's 2,000 liters per hour times 10, so you're going to say 20 cubes per day, and do your selection for the driest month as you want the minimum volume available in your driest month. Click on calculate. Now it's going to give you a bunch of options. Not always necessary to go for the cheaper option. You can give the customer a larger pump for expansion at a later stage, which is always wise. If the hole can only allow a certain amount of water and the customer is convinced that he will never change it, then you can go for your cheapest solution. I prefer not using the smaller panels, as the selection is always a lot easier with the larger panels. Gives the best yield, gives the best performance. Now, he said 2,000 liters per day. This flow rate gives you an average of 1.9 cubes per hour. So you want to increase that. you can go and adjust the solar panels, the quantity. Okay, PS600, we are on the limit. Now, you can go to a larger pump. Right, there we go. That's a better solution right there. It's already 2.2 cubes, 2.3 cubes, so you can have it at an average of about 2,200 liters over 7 hours. I'm pretty sure the customer will be very happy with that. In case the pump is giving too much volume, or 100 or 200 liters an hour too much, you can always open the control box and you've got a volume adjuster in the control box which pretty much controls the frequency of the motor. If you turn it down, it will give you less water per hour, less pressure, etc. So you can easily give the customer that scenario. In the event that you might want to use a pump like this, and you see, okay, 4 square cable, you can adjust the cable lower to suit the customer's existing pump needs. If he's got a 2.5 square cable, he can use the 2.5 square cable. You can also adjust your pipe size. It's not always an issue if your selection turns amber or orange. As soon as it turns red, it will just not do the selection for you. But as a standard, that's closest to what the customer wants. Each and every pump's curve differs. So you'll see it's all PS 1800, that's a PS 1800 HR14, that's the HR14H. Massive difference between the two curves. It's not the same pump at all. Even if you look at the specs, this one's got a maximum 60 meter head, this one's got a maximum 120 meter head. So room for expansion, upgrading is definitely there. Then you can go to click on wiring. We'll give you the basic wiring diagram. In the event that we've got a lot more panels, like it says 5 by 2, 2 banks of 5 panels, gives you the basic wiring diagram. Then you can go click on report. We'll give you all the basic needs for the setup. Motor cable 2.5 square, 20 meters of pipeline, 120 meter, 35 mm inner diameter, 1 probe set, surge protector, etc. And there we go. That's your basic pump selection. It gives you all the curves that you can see. It gives a very wide explanation of the pump along with your wiring diagram and the basic layout of what the system can do. You can click on create report PDF and save it as the PDF and send it to the customer. Myself, just for doing it quicker and more efficient, this whole page gives you all the data that you need. So you can click on your screen cut, do a screen snippet of that, save it as a JPEG and send that to the customer. More than this, they do not really need. If they need a report, you can print out a report, but it takes somewhat longer to generate the report rather than just taking a screenshot. Okay, and that concludes basic pump selection on submersible pumps. Now, pool pumps. Same story, only thing is here we work with the total volume of the pool and the pool pump. Motor cable from your controller to your pump, usually not suggested that it's so far, not supposed to be more than 5 meters from my point of view. Then, do you have a suction head or a positive inlet? Suction head is if your pool pump is higher than the pool. Positive inlet is if it's level or lower than the pool suction weir. So in this case we're going to use a suction head of, let's call it maybe 1 meter. System component losses. As a standard, we've got a 4 meter loss for a sand filter. If for any reason your pipe runs higher, it's a long pipe run, long distance, and your pipe runs higher than the pump or needs to displace through a solar heating system, etc., you add the physical meters to that as well. Your whole pipe length, that is from the mouth of your pool into the weir and from your suction line, your suction line to the pump and your displacement line through the filter back to the pool. That's your total pipe length. On a 50,000 litre, it'll never be 120 meters. you're looking in the region of about, let's call it 20, let's even make it 30 meters. Okay, pipe plastic, most pool installations done with the plastic pipes. Then your swimming pool volume. You can either take the customer's word for what his pool size is, or you can click on the calculator. Different shapes of pools. Normal square pool, let's say for instance the pool is 5 meters, 6 meters long by 4 meters wide. Your shallow end will be 1 meter and your deep end will be 2 meters. You're looking at a 36,000 litre pool. Apply. 36,000 litres comes in there. As a standard, I suggest daily turnover rate of 1.5 times. It just gives you a better curve. In the event that you've got an overcast day or not sufficient sunlight, your pump will still run at a decent rate and give a decent turnaround during that day. Similar as the other selection, click on calculate. It will give you your curve. PS600, two 260 watt panels, 2.5 square cable. Pipe. Pipe is too big, 80 millimeter. Standard pool pipe is 50 millimeters. That's your flow rate, that's your daily pool yield. Now if you look at that, we want 36,000. This is close to 3 times. So you're going to have sufficient cleaning on the pool. The pool's going to be a lot healthier than with a normal or standard pool pump. If you look at the time running, it's 1, 2, 3, 4, 5, 6, 7, 8. It's 9 hours of run time. So if you go back and you calculate, this would be a good equivalent to a 0.75 kilowatt pump. Running a 0.75 kilowatt pump for that duration of time, it's going to work out rather expensive on your electrical bill. But once again, that's your selection. You can give it to the customer. That's 2 module series. You can either print out a report or do a screen clip. Then lastly, surface pumps. That's a pump sucking out of a dam or receiving water out of a tank, displacing it towards either crops or just from a dam or a river towards another tank or dam, just transferring water. Same story, you can select your area where you want it, motor cable, usually 5-10 meters away, same as a pool pump. Altitude, look at, you can go onto Google, Wikipedia, look at the area, the physical location. It will most probably, the internet will give you an altitude, which work on about 1,560. That's above sea level. Then your discharge slide. If you need to run uphill 30 meters in elevation, or you need 3 bar pressure, for every 10 meters in height equals 1 bar. So if the customer says now he wants 3 bar pressure, that's 30 meters. So let's say for instance this gentleman has got a 20 meter incline and he requires 3 bar pressure. It's 20 meter incline plus 3 bar, that's another 30 meters, so it's 50 meter head. Your pipe length towards wherever you want to displace, let's say 400 meters. Let's make it interesting, 4 kilometers. Plastic pipe, you've got once again, let's say a positive inlet. This is coming from a tank or a dam, which is 2 meters higher than the pump. Plastic pipe, same thing, pipe length, you can call it 10 meters, it's fine. And then the amount of water that you want to move. If it's for irrigation purposes, they will ask you for liters per hour, or once again, if it's just water transfer, liters per day. Let's say for instance this is for water transfer and irrigation, and he needs a minimum of 1,200 liters per hour. So you, once again, rule of thumb, 1,200 times 10, it's 12 cubes, 12,000 liters per day. Calculate. Your curve does not accommodate what you want to do. 1,200 liters, yes, you can choke it back, so it will give you more than 1,200 liters at 3 bar pressure for 7 hours, which is perfect, but it's not entirely what the customer needs. This is way more than he needs. So you can click on, firstly you can downgrade on the panels, see if that will help you, if it gives you a more square curve. If not, oh wow, that looked nice. You can utilize that one, it gives you a nice flat curve. It's more than the customer needs, but he can choke it down and he'll get a more even spread of water. Once again, not necessary to go for the cheapest, but if the cheapest gives you your solution, absolutely go for it. If he runs a smaller pipe system, say for instance a 40 or 50 mil inner diameter, that's bringing your flow rate down again, giving you a perfect flow for what the customer needs. So once again, panels are perfect, your cabling, everything is fine. So there's your selection. Do a screen snippet of it, send it to the customer, find out if it suits him, and then you can do a quotation for him. The next video will actually show you how to do a quick quotation, just to give the customer a good cost estimation of what his pump system will cost and what he's in for. And if the customer is happy with that, you can arrange a site visit, work on a turnkey solution, or alternatively just supply component. The pumps are very easy to install. The customers can do it themselves, but you're going to have the odd customer asking you to come and do the installation for him. Thank you very much.